Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
Today we are learning polynomial division starting from the basics and gradually moving to more complex cases. Let us learn how to divide a monomial by a monomial. To understand polynomial division, it's very important that we understand how to divide monomials. Now, for this, we need to know one law of exponent, which is this. Let's see how do we apply this. For this, we divide the first term by minus 9a cube bx square. Now, in algebra, you need to note and be careful about three things. First is sign, then the number, which means the constant, and then the variable. So, first sign. Over here, the numerator is positive. There is no sign means it's positive. So, plus minus is minus. Next, we are dealing with numbers. So, 45 divide 9. So, here we can cancel and we are getting just 5. Now the variable. So the like terms you see, a to the power 6 and a cube. So the powers will get subtracted. 6 minus 3, 3. Now b to the power 2, and here no power means actually there is 1, right? We do not write 1. 1 remains hidden. So b to the power 2 minus 1 is again 1, and we will not write 1. It remains hidden. And x to the power 4. And this 2 will be subtracted. 4 minus 2, 2, which is the answer. Now this is our next question to just test whether you have understood the first one or not. Pause the video and try to answer on your own. Let's solve it like I do. First I'll write the first term and divide by means it goes in the denominator. Remember our rule, sign. So minus minus is plus. We don't write plus as well, so I'll omit it. Next, numbers. So 21 divides 7, which is 3. And the variable a square and a square, since it is same, so it gets cancelled. B to the power 3 minus 2. So that's, we subtract the power. So we are getting just b. So our answer over here is 3b. If your answer matches mine, great. Let's move on to our next part. That is division of a compound expression, that is polynomial by a monomial. This is our first question to begin with. Before we start polynomial division, let's quickly recall how we used to divide numbers in our elementary classes. For example, I have to divide 624 by 5. What do we do first? We look at the first digit, which is 6 over here, and ask what multiple of 5 is close to 6. From the table of 5, we know 5 times 1 is 5, which is closest to 6, right? So we write 1 in the quotient and we multiply 5 and 1 and we write 5 under 6. So this is our step 2. So let me mark over here. Now step 3, we subtract. So 6 minus 5 is 1. That's step 3. And after which we bring down the next digit, which is 2 in this case, and repeat the same process. We again read 5's table and try to find out a multiple of 5 which is closest to 12. In this case, it's 2. So 5 times 2, we multiply 5 and 2 and write down over here, which is step 2. We subtract and bring the next digit down, 4, and our step 3 is completed. And we'll continue this until unless all the terms from the dividend are exhausted. That means they are brought down. Like after this, there are no terms to bring down. So this is our answer. 4 is the remainder and 124 is the quotient. Now the question is, can we follow a similar process for polynomials? Yes, we can. The steps remain almost the same, but there is one challenge. We do not have any tables for polynomials. So how do we decide the quotient? Let's check out. Now to begin with, you need to remember the first rule. The dividend as well as the divisor must be arranged in either ascending or descending powers of the same variable. Like over here, variable is a, so first power is a cube, then a square, then a, then nothing, which means a to the power 0. So it is perfect. Let us look at the divisor. A, which means power is 1 over here, and a to the power 0, which means power is 0 over here, right? No variable, which means power of the variable is 0. So it's perfect to begin with. Remember, arranging terms properly is very important because it helps us match like terms correctly. Now, to find the first term of the quotient, as I've already told you, we do not have any tables for polynomials. So to find the first term of the quotient, remember the rule. We divide the first term of the dividend by the first term of the divisor. So this replaces the role of tables in number division. And you have already learned how to divide monomial by a monomial. So sign, which is positive, number 16 divide 8 is 2, and a to the power 3 by a to the power 1 is 3 minus 1, 2. So this goes in the quotient. The first term of the quotient is this. Step 1 over. Now step 2. First step, we multiply the entire divisor by the result, which is 2a square. Let's multiply. So 2a square into 8a minus 3, and we get 16a cube minus 6a square. And we write this result under the dividend, aligning like terms, which means a cube under a cube minus 6a square. Okay, it means terms with the same powers are written one below the other. Now we have to subtract. That was our step 3. So just like we did in number division. Now in algebra, how do we subtract? We have to change the sign of the second expression. So this becomes minus while this becomes plus. And the first two terms gets cancelled, and minus 46 plus 6 is minus 40a square, and bring the next number down, plus 39a. Then we repeat the same steps. Divide, multiply, subtract until all the terms from the dividend have been used. So here now the first term is 40a square of the dividend and divisor 8a. So we divide these two. So let's do that. So we get minus 40a square divided by 8a gives me first the sign, which is minus, because minus plus is minus. 40 divided 8 is 5. A square by a is a. So our next term of quotient is minus 5a. And we multiply minus 5a with the entire divisor, and we get minus 40a square plus 15a, and we write down under the dividend. Then remember, we have to change the sign. So this becomes plus while this becomes minus. First two terms gets cancelled because minus 40 plus 40 gets cancelled. Now plus 39 minus 15 gives me plus 24a, and we have to bring minus 9 down. Once again, we'll repeat step 1. So we'll divide the first term, that is 24a, by 8a. And aa gets cancelled. 24 divided 8 is 3. So plus 3 goes in the quotient. And we multiply 3 with the entire divisor, and we get 24a minus 9. And we write down under the dividend, maintaining the like terms, sign changes, so minus, this becomes plus, and this gets cancelled, because minus 9 plus 9 gets cancelled, and we are getting 0. So the remainder is 0. So we see the polynomial division follows the same idea as number division: divide, multiply, subtract, and repeat. The only difference is that instead of using tables, we divide the leading terms. Now once you understand this pattern, polynomial division becomes much easier. So here the quotient is, and the remainder is 0. Now tell me, so far everything was neat and straightforward, isn't it? Now what happens if things are not so perfect? Suppose the terms are not arranged properly and we are not getting 0 remainder. So let's see how to deal with this. For example, in this question, you can notice the terms are not arranged in the descending order of the power of the variable. Here the variable is x, and clearly we have to look for the highest power of the variable, which is clearly x to the power 5. That means this should be the first term. Then the term containing x to the power 4, which is 2. Then the term containing x cubed, 3. Then x squared, so 4. And then we have term containing x5, and then this one, 6th term, right? Again over here, this should be the first term because this is the highest power of the variable. Then this should be the second term, and this should be the third term. So let's rearrange it. When you're rearranging, you have to make sure that you're writing proper sign. Like over here, 6x to the power 5 is having a plus sign, so positive. Then the second term is minus x to the power 4. Third term is 4x cubed, so plus 4x cubed. Fourth term is minus 5x squared. Fifth term is minus 3x. Sixth term is minus 18. Divide by, again over here we arrange 2x squared minus x plus 3, because 3 is positive, right? Now we'll divide it. We are all set to divide. Remember our rule. First, we need to determine the first term of the quotient. How do we determine that? For that, we divide the first term of the dividend by the first term of the divisor. So we get 6 divided 2 is 3, x to the power 5 minus 2, which is 3, which goes over here. And exactly with this, we multiply the divisor. So in this case, it is 2x squared minus x plus 3. And we get 6x to the power 4 minus 3x cubed plus 9x squared. The entire thing goes under the dividend, but under proper column. So we divide now 3x cubed with the divisor. So we multiply 3x cubed with the divisor, and we get 3 times 2, 6, x to the power 5 minus 3x to the power 4 plus 9x cubed. Then we write this under the dividend, making sure that we write similar terms together. For example, x to the power 5 under x to the power 5. So x to the power 4 together. Then plus 9x cubed. Changing the sign throughout. This is the most vital step. So the sign of the second expression changes throughout. For example, this becomes minus, this becomes plus, and this plus becomes minus. These two gets cancelled. Now plus 3 minus 1 is plus 2x to the power 4. Here minus 9 plus 4 is minus 5x cubed. And then the next number down, which is minus 5x squared. Now we repeat the same process again, step 1, step 2, step 3. Step 3 is subtracting and bringing one term down, that is the next term down, until all the terms in the dividend are brought down. So let's do it very fast. Again, step 2. For step 2, we divide the first term of the dividend by the first term of the divisor. So like this, we will repeat one more time. So I'll make space over here. I'll delete step 1 and step 2, already done. Let's start over. First step, divide the first term of the dividend by the first term of the divisor to get our next term of the quotient. Don't forget the sign. And I did forget, so it's minus 2x. Step 2, with minus 2x, I'm going to multiply 2x squared minus x plus 3. I hope my minus is visible. So I'm getting minus 4x cubed plus 2x squared minus 6x. I'm going to write this down over here under proper column and change signs. This becomes plus, this becomes minus, and this becomes plus. So simply first two terms gets cancelled. Minus 8 minus 2 is minus 10x squared. Minus 3 plus 6 is plus 3x. And the next number down, minus 18. Now you know what to do. Again, we will repeat the same steps. I'm not highlighting anymore, so let's just fast forward. Now changing the sign throughout. And first two terms gets cancelled. Plus 3 minus 5 is minus 2x. And over here, minus 18 plus 15 is minus 3. Now that we have learned how to divide and find the remainder, what if we want the division to be exact? For example, if this question would have been this. So here we have been asked what must be subtracted from that previous same expression I have used so that the resulting polynomial is exactly divisible by this. So we divide after arranging the terms, of course, using the same process we have learned so far, and we get the remainder. Now remainder is the key answer over here. Now over here the answer, final answer will be, because we have been asked what must be subtracted. So remainder is the extra portion here. If we want this dividend to be exactly divisible by this divisor, we have to remove this remainder, right? Then only the division will be exact. So in this case, what must be subtracted? The remainder must be subtracted. So our answer will be minus 2x minus 3, that is our remainder, must be subtracted. Now, in place of subtracted, what if we are given, what if the question asks what must be added in place of subtracted to make it divisible? So at first this may feel confusing, but think carefully, our goal is still the same. We want the remainder to be 0. So we can add the negative of the remainder. Why does this work? Because when we are adding the negative of the remainder, it is same as subtracting, right? So when we are adding, let's say, minus r, it means subtracting r, right? It is same as subtracting r. So when we add the negative of the remainder, we are actually cancelling it out and the remainder becomes 0. So here the answer will be, so negative of the remainder means we change the sign of each and every term. So it becomes 2x plus 3 must be added. In case our question comes like this, what must be added instead of what must be subtracted. So remember, if the question says subtract, subtract the remainder. If the question says add, add the negative of the remainder. In both the cases, the goal is the same, to make the remainder 0 and the division exact. Hope you have learned something useful today, and if this helped you, don't forget to like the video and keep supporting. Stay kind, keep practicing. I'll see you in the next lesson.